Hello everyone, my name is Eman Al Antary. I'm a third-year Hematology Oncology Fellow at Children's Hospital of Michigan. In this poster, I summarize my so far results on my project entitled Novel Therapy for Cytarabine-Resistant AML, utilizing the combination of AZD5991 and ONC213. Resistant to cytarabine-based chemotherapy is the main cause of treatment failure in acute myeloid leukemia. Therefore, new effective therapies against RSC-resistant AML are urgently needed. The anti-apoptotic protein MCL1 and oncoprotein c-Myc are overexpressed in AML. Studies have shown that they are associated with RSC resistance, disease relapse, and poor prognosis. Therefore, targeting MCL1 and c-Myc in RSC-resistant AML is a rational therapeutic option. In addition, recent studies have shown that RSC-resistant AML cells rely on oxidative phosphorylation. Thus, targeting OXPHOS may represent another rational approach to combat RSC-resistant AML cells. We believe there are two drugs that can do this job. First, AZD5991, which is a selective MCL1 inhibitor. Studies have shown that AZD5991 is effective against hematological malignancies, specifically AML. Our preliminary studies shown that knockdown of MCL1 or inhibition of c-Myc significantly enhanced the anti-leukemic activity of AZD5991. Therefore, the combination of AZD5991 with a therapeutic that downregulates MCL1 and c-Myc should enhance the anti-leukemic activity of AZD5991. We believe that ONC213 can be that therapeutic option, and that will be our second drug. ONC213 is a novel second-generation emperadone. Our preliminary studies demonstrate that ONC213 potently suppresses OXPHOS, downregulates MCL1 and c-Myc, and induces apoptosis in OXPHOS-dependent AML cells. Therefore, we hypothesize that ONC213 will synergistically enhance the anti-leukemic activity of AZD5991 against RSC-resistant AML cells. To test our hypothesis, we aim at studying the in vitro anti-leukemic activity of this novel combination against RSC-resistant AML cells and studying the underlying molecular mechanism of action. We used Western blotting, flow cytometry, and MTT assays to conduct this project. First step, we generated RSC-resistant cell lines as shown in Figure 1A. In Figure 1B, you can see how these RSC-resistant cells have decreased or absent DCK, which is a rate-limiting enzyme in converting RSC to its active form before incorporating into the DNA. Second, we showed how RSC-resistant AML cells interestingly overexpress only c-Myc and MCL1 as shown in Figure 2. Then we treated these cells with ONC213 at different concentrations over 24 and 48 hours, showed that ONC213 downregulates MCL1, c-Myc, and RSC-resistant AML cell lines, and alone can only partially overcome RSC resistance. And this is seen in Figure 3. Therefore, we start studying another strategy to combat RSC resistance by combining AZD5991 and ONC213. And we have shown that this novel combination has significant synergy in inducing apoptosis in RSC-resistant AML cells, as shown in Figure 4A and C, either at same time or sequential treatments. This effect was also reproduced in patient samples with AML, as seen in Figure 4D. Figure 4b showing that increased cleaved fragments of caspase-3 and PARP, indicating that this anti-leukemic activity of this novel combination is through extrinsic apoptosis. Then the question comes, what is the mechanism behind this significant synergy? And we found that it is secondary to downregulation of MCL1 and c-Myc, as shown in Figure 5A to C. Finally, as we shown that AZD5991 induces apoptosis through extrinsic pathway, we also found that AZD5991 anti-leukemic activity can also be through intrinsic apoptotic pathway by using shRNA knockdown of back and backs model, as seen in Figure 5D and E. Based on so far results, we conclude that ONC213 synergistically enhances AZD5991, induced apoptosis in ARSI-resistant AML cells mediated by suppression of both MCL1 and c-Myc. Currently, studies are underway to determine the role of OXPHOS in the synergistic anti-leukemic activity of ONC213 and AZD5991 against ARSI-resistant AML cells and in vivo efficacy of this promising combination therapy. We believe that these results of this study will form a solid foundation for the clinical evaluation of this promising combination therapy to combat ARSI-resistant AML in children, which may also be applicable to AML in adults. Thank you so much for your listening, and please feel free to reach out to me for any questions.